These teams' use of PID controllers is still kicking my butt. And while we're struggling with that, we're also trying to learn how to use this command robot pattern. So let's take a look about how we ran this last attempt to move the elevator motor and why this was dangerous. Our first problem is that we're defining the motor right here and not creating a separate subsystem for the elevator motor. So now we'll move the elevator motor from here to this new elevator subsystem that I've created here. Now this subsystem, the robot runs essentially from this file. It runs as if it was a static class. And so that's why its instance variables are static. And that's helpful because from any other file, I can just call capital R robot dot and then access any of these public variables. But if I paste the motor here, it's going to be upset that I'm declaring it statically if I'm then going to be instantiating the new drive later on. So we'll get rid of that and we'll import the Jaguar. You'll also note that I moved our magic numbers to the robot map as they're supposed to be. Now once we understand a PID subsystem better, we can change this over to a PID subsystem and also bring in an encoder on this elevator motor. So that way we can tie the motion of the motor to the readings from the encoder so that we can get a very smooth motion and figure out the P, the I, and the D in order to get that very elegantly moving. Now let's go ahead and raise and lower the drive command. So we can have a lift raise command like Java and a lift lower command like Java. Before I can start programming these commands, I'm going to need to instantiate the elevator here, and because I'm creating it new here, that means it's being instantiated. That's again why I took the static off of the variable that I created in the elevator class, because I'm creating a new one here that'll be in this instance. And yet robot runs in a static format, so its variable is static, but the stuff that's inside the elevator won't be. Anyway, we were talking about static and instantiated before, so I just was trying to clarify that. So I've got my elevator subsystem set up, and it's being declared in my robot. So now if I'm programming out these two commands, I just copy the code from before, rename these, and instead of the drive, I'll have my elevator. I'm going to need to refer to it from here. It's public, so I'm setting up private things just to make it a little bit easier. So I'm just going to be pointing to the same thing. So robot.elevator. Now instead, I could just type in robot.elevator everywhere, but I'm creating another copy of this pointer. It's not a new object. It's just a new container, a local container that will allow me to point to the same variable that's being held in that file. So just a shortcut. So it will require this elevator system. When I raise, I don't need to initialize much of anything. All I'll have to do, initializing could be very useful if I was trying to set like a PID target, or I don't know what I'm talking about there. But execute will be easy enough. While I'm executing, all I have to do is apply power to this elevator. So elevator, get your elevator motor and set power. Set power. Set position. Stop motor. Was it power? What were we doing before? In robot like Java, while the button was being held, we wanted to, oh, just set. Okay. Yeah, that worked. So Lord raise command, set, and we could just go 0.5 speed, for instance. Again, this is all manual on off and not using paper control to smooth it out. The nice thing about this command structure is that it'll auto call the end when this is finished, which it'll keep on checking, returns true. So what happens when this command is told that it's finished? Well, we'll set the elevator motor to 0. So that way. So, and now how will it tell if it's finished? Well, we can have a button. So as soon as the button that gets pressed when the elevator is raised is triggered, then it returns finished. But we can also say, as long as the button is still being held. And I moved the buttons to OI, so they're being held here. So this X button, or what button were we thinking about? Let's take a look in robot. We were looking at get raw button 4. So what is button 4? That's the Y button. So it's way easier if we just call it the Y button all the time. And so that way I can, so we say, hey, get the Y button and just get its current value. And if that's not true, so if it's the opposite, then I've let go the Y button. So yes, you're finished. So if it is true that it's returning true, you're currently in a state of being triggered, then return false. I'm not done yet. The button is still being pressed. The alternative, the other way I could write this potentially, and I don't know, I haven't tested this to see if it works, but I could also, if I didn't have this line, I could also return OI, get the whole gamepad, and get the raw button state of, now I need to know what port the X button is. And unfortunately, that'll always be the same. So these button numbers will always be the same. So I might as well put that down inside my magic numbers in case I ever wanted to refer to them. There. Now I made a reference to all of these button ports in case I ever wanted to refer back to them. So, and they're publicly accessible. So now if I was writing an alternative to this, I could say, okay, it's the Y button. So I could say robot map, get the Y button number. So, and it's when that's not true. So this can be redundant. So is finished. I could also just return false. I'm never finished. Because over in teleop periodic, when I'm pressing buttons, what I'll do here is I'll set, hey, input output, or the Y button, when it's pressed and only when it's being held down, do a new lift raise command. Y button. So it'll automatically disable that when I'm let go. So now this should be redundant. So when I'm let go here, it should automatically trigger the end condition in the raise command, and the end condition is this. But it'll also trigger the end condition and terminate this command when I let go based on this reading. So it should, it's extra safe, or maybe I'm creating a conflict because the two places are going to be watching for when I let go. I don't know, but I think this is much safer than this approach. So if this is this is the Y command for the raise, we'll want the opposite for lower. Now let's do the same thing to this stuff that we just did with the other button presses. How we moved it into a command with dedicated conditions onto when to end it and safety measures that when it's ended, it automatically shuts down the power to that motor. So similarly, we're just going to put it into a drive command. It'll do this similar sort of stuff with safeties. But instead of looking for it pressing, I'm just going to create it right away. And this thing won't end as long as teleop is running. The drive command will be running and will be watching out for my X up and down and left and right on the joystick. Look how much smoother and easier to understand our periodic has gotten. But let's go do this drive command. So we're not really moving to a target, so we don't need to have any sort of target. It doesn't need to be a PID command because we're not tuning it to any smooth motion. We're just using the drive station, and so as long as we're driving, we'll use this drive apparatus. We'll apply the arcade drive, but not as a fixed point, but rather as get the OI and get your gamepad, and then get the Y-axis. What was I using before? Here, I have it pasted. Before I was using right here, get raw axis. So this is, well, actually I can use all of this right here. I just replace this drive, get rid of this, and we're still doing a manual dead zone. We can improve that if we wanted to, but this is fine. It's the exact same thing, and it's finished will never be finished, so we're always done. But once you end it, I'll set the power. I don't need to have all this. I mean, this is the exact same reference, but instead of, I'll just use the local drive because I set up a variable for the local drive, and it imports that thing right here. So so when we end, we cut all the power, and if we are interrupted, we also cut all the power. But this way, the joystick is being monitored from this particular drive command. So it's a little more elegant this way. So I'll commit and push these changes. Have a look at some of the things that I've been moving around. See if you can think of any questions. Will it work? We have no idea. So we're going to keep on testing. This is all new stuff for me. So we're going to test this out, and we'll keep on hammering at it until we get it moving, and then we'll iterate and improve after that. But yeah, take a look and let me know if you have any thoughts.